Yes, so this all is basically when we are going to label the when we are going to label this uh, coil, I mean motor question, we must know its parts. And when we are going to explain the working of the DC motor, we must know that from where the current is flowing and what would be the direction of motion of the motor. So if I just show you this one, कह रहा है कि first one labeled वाला आपका हो गया, it is done. Then state the magnetic poles X or Y is north. So which one is north? Because the coil is having the current from A to B, because I have labeled side A, B, C, and D. So if I consider the side near X pole, right? What is that? The current is coming from A to B. So force is where? Force is in upward direction. ये देखो force का arrow मैंने draw किया था, and this force arrow is basically upward. So when you will the point your finger, middle finger towards you, and thumb upward, then automatically the magnetic field would be pointing towards right. So magnetic field pointing towards right mean north is on the left side and south is on the right side. That's why X is your north and Y is your south. Okay, got it?
Got it.
Okay. Then I told you the question is suggest two factors that causes the motor to spin faster. So I told you that number of turns can be increased, area of the coil can be increased, magnetic flux density, yani magnetic field strength can be increased, and the current can be increased in the coil to make it rotate faster. Okay, is it clear to you?
Clear, sir.
These are four factors you have to recall. Then suggest two changes that cause the motor. Okay, okay, I have written it down. State the effect on the motor of reversing the connections of the battery. So when we are going to reverse the connections of the battery, then what will happen to the direction of motion? The direction of the motion will be reversed. Is it? So for
Yes,
that
sir.
one, I told you three things, that force is reversed. I mean, the rotation is reversed either by reversing the magnetic field strength or battery, I mean current. But if you will reverse both of them, nothing will happen. Okay, is it clear to you?
Can you explain C again, sir?
Yes, I'm saying that if you will reverse the magnetic field, then current, I mean, direction of rotation will be reversed. R focus is on R. If you reverse the direction of current, it would be reversed. Okay. If you are going to reverse both of them, it would not reverse. Got it?
I've got
Sorry.
it, sir. Also, sir, one question. This is not related to physics that much, but it's
Mhm.
telling me that my laptop fans should not be blocked because मेरा laptop ना बहुत बुरे से overheat हो रहा है अभी. तो
Mhm.
what does it mean by that it shouldn't be blocked? Like I shouldn't have any surface underneath the laptop?
Yes, it would be covered. Okay. Your
Okay, so I should
laptop.
just like hold the laptop in the air for a while.
Yes, I did the same. I can send you the picture. Huh? Assalamu alaikum, sir. जी अस्सलाम वालेकुम. हाँ जी सर.
सब खैरियत से ठीक है
जी शुक्र अल्लाह का.
अच्छा सर आज आप जा रहे हैं इंशाल्लाह अल्लाह खैर करे
अल्लाह खैर करे तो इंशाल्लाह. मैंडेटरी नहीं है, इनविटेशन थी, वही वो जो मैंने आपको बोला था इनविटेटरी है. तो
ठीक है हाँ
ठीक
जी
है. हाँ ये
हाँ जी
तो
तो सर अपना फैमिली को ले आए कोई issue नहीं
नहीं कोई इशू नहीं, आप ले आएं. मैं भी कोशिश करूंगा बच्चों को अगर रेडी हो गए तो ले जाऊंगा. ठीक है.
चले अल्लाह खैर करे इंशाल्लाह
ठीक सर. अच्छा, इसको ना तुमने अनकवर रखना. जैसे फॉर एग्जांपल मैं तुम्हारे पास फोन है अभी?
Yes, sir.
यस सरीबा. ओके सो हेलो आउट. I made some drill holes in my laptop. I mean laptop body, not in laptop. Sorry. ठीक है ना ताकि एयर क्रॉस हो. So you have to keep the laptop in different situations. For example, मैं तुम्हें समझाता हूँ मैं लैपटॉप को कैसे रखता हूँ. I just place the laptop just like a tent. Okay. And due to that, there is a channel of air which is not covered. Otherwise, if I will take that, I will put the laptop in the normal condition. You know what will happen? The fan or fan area will be covered, and when fan area will be covered, at that time it would be overheated. तो आपका वो clear हुआ है?
Sir, I don't really understand what you're saying. Could you please repeat?
Yes, I'm saying that where is your laptop? I mean, where did you put the laptop right
Like,
now?
it's in my lap, sir.
Okay, so just try that it should not touch with your thighs. थोड़ा सा ऊपर रखो इसको.
Okay, sir. I'm holding it that way now.
या इसकी वजह ये है कि if it will be touching your body like air, इसका air channel कहीं से होगा on the sides. ठीक है ना, इसलिए मसला कर. अब ये देखो वीडियो तुमने देखा पिक्चर?
I haven't received anything. Let me check. Okay, yeah, now I can see. Yes, sir.
इसको तुम जरा जूम करके देखो सबसे पहले वाली पिक्चर को. So I made all these holes manually by drill machine. ठीक है
Oh,
ना.
mashallah.
ठीक है. इट वॉज हैविंग जस्ट अ स्मॉल ओपनिंग फॉर एयर पैसेज. तो ये सारे जो रैंडम होल्स हैं ना ये मैंने इससे किए हुए हैं ड्रिल मशीन से. फिर मैं तुम्हें दिखाता हूँ. ये लैपटॉप में ऐसे रख के पढ़ा रहा हूँ अभी तुम्हें. तो इट्स एग्जॉस्ट इज कमिंग आउट फ्रॉम दीज होल्स. नजर आ रहे हैं ये जो विल बी रिवर्स के बिल्कुल सामने ये जो
जी.
छोटे से 1 2 3 4 5 6 7 8 9 10 बटन्स टाइप लग रही है. ये बटन्स नहीं है, ये बेसिकली इसका एग्जॉस्ट है. ठीक है.
Okay. That's neat,
यस.
sir. 5-minute crafts की तरह.
हाँ. तो इसको ना बस आप ऐसे रखो, टेंट फॉर्म में रख दो. लेकिन तुम्हारा 360 रोटेशन वाला तो नहीं है?
360 rotation वाला है, but the touch screen is broken.
ओके खैर है, कोई मसला नहीं. और इसको जहां पड़ा हुआ ऐसे ही छेड़ना नहीं है. ठीक है.
Okay.
ओके सो यस आई वाज सेइंग दैट either reverse the direction of magnetic field or reverse the direction of current, then the direction of motion will be reversed. ठीक है. rotation of the motor will be. आपने ये याद रखना है. just recall that. और recall के लिए आपने क्या करना है कि F is reversed. how? if F मतलब force rotate, force reverse होगी तो direction of motion भी reverse हो जाएगी ना. तो force is reversed if either B or I is reversed. तो B is reversed by reversing the poles. ठीक है. And I is reversed by reversing the battery terminals. Is it clear?
Yes, sir. Clear.
Okay. So the next is what will happen to explain why the current in the sorry, the battery in figure 9.1 is placed with the replaced with a resistor, and the coil is now made to rotate externally. Explain why there is a current in the coil in the resistor. तो इसके लिए आपने याद रखना है कि there is a situation that this coil is now rotated externally. ये देखो मैंने उस दिन डायग्राम बना के समझाया था कि this coil is now acting just like a generator. And in generator, when you rotate it, what happens? It cuts the magnetic field lines, and due to cutting of magnetic field line, a current is induced in the coil. तो आपको मैंने ये बताया कि the magnetic field lines and the flux is induced. Magnetic field lines are cut. यहाँ पे हाँ मैंने ये लिखा हुआ है. The coil cuts the magnetic field lines. ठीक है. Did you see this? Coil cuts the
Yeah.
magnetic field lines, and flux is induced. Flux is a word number of field lines. ठीक है? It causes the induced current in the coil resistor. That's it. ठीक है? आपने सिंपली ये दो तीन पॉइंट्स याद रखने हैं. When a coil rotates in the magnetic field, it cuts the magnetic field lines. What does it do? It cuts the magnetic field lines. ठीक है? ठीक
I've
है?
got it, sir.
When magnetic field lines are cut, what happens? The coil causes an induced EMF.
And induced?
Induced EMF. Induced
Okay.
means temporarily produced. Induced means temporarily produced EMF. Okay.
Yes, sir. I've got it.
Okay. Now, this was, I think, part A of maybe question number 5, and in that question, it is asked to you कि आपके पास क्या फिगर. हाँ, क्वेश्चन नंबर 2 का पार्ट 5 पार्ट ए है. कह रहा है कि 10.1 shows the gap between north pole and the south pole of the magnet. ठीक है. The magnetic field in the gaps is uniform. Uniform magnetic field के लिए मैंने आपको क्या बताया था? You have to draw 4 parallel lines with same spacing, equal spacing. ठीक है. Clear?
Clear, sir.
Okay. Then next में मैंने आपको ये बोला, next question is कि what you have to do. On figure 10.1 draw, okay, 4 magnetic field lines, ये भी हमने कर लिया. Then in this diagram there is a horizontal coil, copper wire PQ, ठीक है, between the opposite magnets north and south के बीच में ये पड़ी हुई है. A circuit is made by connecting the sensitive digital emitter between P and Q. The wire P and Q is moved vertically downward. Moved vertically downward. ठीक है, wire is moved vertically downward. सारे ये दरवाजा बंद कर दो बच्चा. P is moved vertically downward. तो क्या करता है कि state and explain what is observed on the emitter. तो as I told you कि state and explain means it is of 3 marks. तो मैंने आपको ये बोला कि आपने क्या लिखना है सबसे पहले कि when the wire is moved it cuts the magnetic field lines. या बल्कि आप ऐसे कर लो, state कर लेते हैं पहले. State, what is observed? Deflection is observed. What is observed? Deflection is observed. Deflection होता है motion. ठीक है, 1 mark. You have scored 1 mark. अब आपने क्या करना है? You have to you have to explain it. ये हो गया state वाला part और ये आपके पास है explain वाला part. तुमने ये यूज करना है? पता नहीं, मुझे नहीं पता. यूज करना है मैंने, मेरे पास ये है पड़े हुए, तुम ले जाना. ओके. एक्सप्लेन में क्या है? आज मैंने हेडफोन है ना, तो सारे मुझे कहते हैं मैंने यूज करना, मैंने यूज करना. एक्चुअली मैं कंप्यूटर मार्केट गया था. देयर वर सम एसेसरीज रिक्वायर्ड फॉर कंप्यूटर, जिसमें मेरे कंप्यूटर का बच्चों ने कीपैड भी थोड़ा सा डैमेज कर दिया है. फिर साथ में कुछ और चार्जर वार्जर भी ब्रेक हुआ था, लेकिन कोई सही चीजें नहीं मिल पाई. तो अभी सिर्फ हेडफोन हमें अच्छे मिले, तो अब ये सारे कह रहे हैं मैंने, मुझे चाहिए, मुझे चाहिए. अच्छा, एक्सप्लेनेशन में
I
आपने ये लिखना
suppose
है
that's the
हमेशा
life
ये
of
दो
a
पॉइंट्स.
father.
हाँ.
I suppose that is the life of a father then, sir.
यस. उन्होंने कहा अब जी आपने 10 मिनट ये यूज कर लिए ना, बस बहुत है ना, अब हमें दें जरा. एक्सप्लेनेशन में आपने ये लिखना है कि व्हेन अ वायर इज मूव्ड, व्हेन अ वायर इज मूव्ड in magnetic field, in magnetic field it cuts the magnetic field lines. It cuts the magnetic field lines. यही इसका प्रॉपर आंसर है. ठीक है, no other answer is there for any question in which it is asked कि why current is induced due to motion of the wire or the coil. आपने यही पॉइंट्स लिखने हैं कि when the wire or the coil is moved in the magnetic field it cuts the magnetic field lines, it causes an induced EMF in the coil. यहाँ पे वायर है तो वायर लिख दो, अगर कॉइल है तो हम लोग कॉइल लिख लेते हैं. दैट रिजल्ट्स अ करंट. ये एडिशनल है, ये क्योंकि उसने रेजिस्टर से पूछा हुआ है. दिस इज नॉट ऑल द वेज अप्लाइड. दैट रिजल्ट्स अ करंट इन resistor. Okay, is it clear to you?
Yes, sir. Could you just like write the definition of deflection somewhere though, so I can remember it?
Oh, okay, okay. Deflection means movement, fluctuation. ठीक है, फ्लक्चुएशन.
Yes, sir.
मीटर में
I've
ना,
got
मैंने ये तुम्हें बना के दिखाया भी था, अगर तुम्हें याद हो. मैंने कहा था ये मोटर है, एंड इफ यू हैव दिस दिस इज द डिफ्लेक्शन, दिस वे. जैसे हॉरर मूवीज में नहीं कर रहा होता, वोल्ट मीटर लगाते हैं कहीं पे, एंड यू शो के
Yeah.
ओ, दैट इज द डिफ्लेक्शन. ठीक है, गॉट इट.
Yes, sir. I've got it.
ओके, गुड. The next is yours. क्वेश्चन क्या है आपका? Observed on, state what is observed on the emitter when PQ is when PQ is moved. ठीक है जी, when PQ is moved. So आपने PQ को मूव करवाया. So what did you यानी PQ is moved vertically downwards with a greater speed. ठीक है, अब आप देखो, initially it was moved vertically upward ना. If you see that, I have shown this all. Initially it was moved upward, so current was uh, towards you. ठीक है, deflection was in one direction, but when you have reversed the direction of motion, current would be reversed. ठीक है, और when you have moved it faster, तो more deflection is shown, more current is there. ठीक है, ये दो तीन बातें आपने लाजमी याद रखनी है. मेरी आवाज आ रही है अब तुम्हें? क्लियर?
Yes, sir.
अब आवाज में कोई फर्क आया?
आप फिर से बोल सकते हैं, sir?
मैं कह रहा हूँ वॉइस में कोई डिफरेंस आया? इज एनी डिफरेंस
Uh, not
प्रीवियस
really.
एंड दिस? रियली? ओके, ठीक है, गुड हो गया. ओके जी, सो मूविंग फॉरवर्ड. ये क्वेश्चन क्लियर है आपको?
Yes, sir.
ओके, जल्दी से इस पे आइए.
Sir, your screen is frozen.
ओह माय गॉड, मैं दोबारा शेयर करता हूँ. देखो, चेक कर लेना चार्जिंग वार्जिंग सारा कुछ प्रॉपर, देन वी विल फाइनलाइज. अच्छा, अब देखो, स्क्रीन शेयर हो रही है? हेलो?
Yes, sir. I can see it now.
ओके, ओके, सो आई बिलीव दैट इट विल वर्क. मूव कर रही है?
Yes, sir. It's moving now.
ओके, ओके, जल्दी जल्दी इसको वाइंड अप करते हैं, क्योंकि आगे क्वेश्चंस हमने काफी सारे करने हैं. वो कह रहे हैं कि हाँ, the vertically upward with the same speed. So vertically upward means current will be moving in the same direction. ठीक है, deflection will be in the same direction, but then what will be what will observe? The direction of motion is same. और अच्छा, पहले वायर मूव कर रही थी डाउनवर्ड. वेट 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 वेट, आई थिंक सॉरी आई मेड अ मिस्टेक. पहले भी वायर आपकी किधर को मूव कर रही थी? डाउनवर्ड्स. PQ is moved. हाँ, it is written here. Initially the wire was moving downward. So when the wire was moving downward, actually the deflection was in one direction. So when deflection is in one direction, what did you notice? If you will deflect it more quickly, then its deflection will be faster. अगर आप इसको वायर को जल्दी मूव करोगे तो डिफ्लेक्शन क्या हो जाएगी आपकी? फास्टर हो जाएगी. ठीक है, क्लियर है?
Yes, sir.
रिबा, आपको आवाज आ रही है मेरी?
Yes, sir. I think maybe it's coming a little bit delayed, but I am getting it nonetheless.
एक मिनट, क्यों लेट आ रही है?
Probably my internet or my load.
जस्ट अ सेकंड. तुम क्या गेम खेल रही हो 3D पे? फिर क्यों आ रही है? तुम्हारी लोड क्यों है? एक तो वाईफाई की रेंजेस का भी बड़ा मसला होता है. ओके, आई जस्ट मूव्ड 1 meter. I got 2 more signals. Now is voice clear?
Yes, sir. Your voice is clear.
ओके, चलते हैं आगे, चलते हैं. स्पीड पकड़ो शबश. ठीक है, जहां तक इसमें अंडरस्टैंडिंग में कोई इशू तो नहीं है?
No, sir.
ओके, देन हाँ, मैंने वर्किंग प्रिंसिपल ऑफ ट्रांसफार्मर यहाँ पे लिखवाया बिकॉज देयर वुड बी अ क्वेश्चन अहेड which was dealing with the transformer. This is that transformer. ठीक है, तो in transformer I told you that you have to remember these 4 points. The working principle of the transformer is that an alternating current causes an alternating magnetic field in the primary coil. Yani, what is the property of alternating current? Alternating current varies. When current varies,
Right.
it produces a variable magnetic field in the primary coil. And when this when this variable magnetic field is connected or linked to the secondary coil by core, then the field lines are cut. ठीक है, second stage पे क्या होता है? जो magnetic field produce होती है, that magnetic field is transferred. That magnetic field is transferred to the secondary coil by core, and the core um, uh, links it to the secondary coil, and secondary coil causes the cutting of magnetic field. Secondary coil क्या करती है? Magnetic field को cut करती है. When magnetic field lines are cut, EMF is induced in the secondary coil, and that is your output voltages. ठीक है?
Yes, sir.
ओके, मैंने 6 o'clock तक वाइंड अप करना है बिकॉज 6 o'clock मैंने आगे किसी और जगह पहुंचना है. सो इसलिए वी विल मेक अ पेस, और मैं कोशिश करता हूँ कि अगर हम बजाय इसके, ये वाला क्वेश्चन है, ये वाला, हाँ, यहाँ से शुरू करें जहाँ से हम लोगों ने नहीं किया हुआ. आगे ट्रांसफार्मर का क्वेश्चन आएगा, मैं तुम्हें बता दूंगा. राइट?
Okay.
आर यू एग्रीड? ठीक है,
Yes.
I will try my best कि you will not get any confusion in that. Carry figure 10.1 shows the cross sections of the wire carrying the current into the plane of the paper. So, as I told you, it is connected. As I told you that if there will be a current in a wire, that current in a wire will be basically either outward or inward. So this current is out of the page. So when this current is out of the page, क्रॉस है ना ये, सॉरी इनटू द पेज है ना, क्रॉस है. सो फॉर द क्रॉस आई टोल्ड यू दैट क्लॉकवाइज, cross clockwise circles would be there. And because it is of 3 marks, so you have to draw the circles closer near the wire and separate it outside. ठीक है, concentric circles should be there. ठीक हो गया? And then the direction of the circles should be clockwise, cross clockwise. You please remember this thing, that when there will be a
Got
wire,
it.
and in that wire the current is shown into the page, then magnetic field would be clockwise. If we have the same wire and the current is out of the page, out of the page का मतलब क्या होता है कि we are having a dot. So for dot means thumb is pointing towards you. When thumb is pointing towards you, it means the circles would be anti-clockwise, out anti-clockwise. ठीक है?
Got it, sir.
Okay. The next is On figure 10.1, sketch the magnetic field due to the, okay, ये हो गया, done. Next figure 10.2 shows the part of the model of a DC motor. Take a part of the model of the DC motor. A loop of wire A, B, C, D is placed between the poles of the wire. ठीक है? Between the poles of the wire, this one. The loop is free to rotate about the axis. Field is free to rotate. देखो, current is shown there. There is a current in the loop and uh, the direction indicated by arrows. Current का direction भी given है. On figure 10.2, draw the arrows to show the direction of the forces acting on the side AB and on side CD of the loop. Okay, carry on. Tell me what would be the direction of the force. How will you go to that? By applying your three finger rule. तो सबसे पहले आपने क्या करना है? Where will you point your first finger? This is your index finger. ठीक है?
I
This
would
is your
be
index finger.
pointing it.
A B पे दिखा दो.
I'm sorry.
Okay, if you are convenient to show on CD, then show me on CD. Where in whatever the side you are convenient for, you can show me the direction of force on that one.
From C to D?
Current is from D to C, na? Check
It's
karo.
from D to C,
So
no?
where should be? So where should be your finger pointing? Yani middle finger pointing
My middle finger's going slightly upwards.
in this way.
Yeah, so my thumb's also upwards.
ये middle finger हो गया, ये आपका index finger हो गया, ठीक है? And your thumb is pointing out of the page. Is it?
Yes.
Out of the page. So it means the force will be here in this direction, and on that one force will be downward. Is it?
Yes, sir.
So आपने किसी एक side पे force find कर ली, so definitely current is reversed, so force will be definitely reversed. So force was upward. Got it?
Got it.
Okay. Next, you have did it. I mean, you are done with that one. Okay, Karak, the wire of the loop is the position on the. This explain why the force on AB and CD cause the loop to rotate about the axis. So this is very easy question because both the forces are acting in opposite direction, right? And they are behaving like, are they are producing the turning effect. It's very simple explanation. One force is acting downward, other force is acting upward, and coil is pivoted from the center, so it will cause a turning effect in the coil. ठीक है? तो आप लिखोगी, should I write? The forces cause turning effect in the coil as they are equal and opposite in direction. Equal and opposite and acting on the and acting across the pivot. Got it?
Got it.
Is it clear, beta?
Yes, sir. One thing,
Okay,
since it's only from one mark, wouldn't we write
one mark.
only
So
like
yes, yes,
one
yes.
sentence?
No need to write this all the ways. This one from this point to this point. Okay. It when you will write, it will cause turning effect. That's why call rotates. That is perfect. Okay.
Okay, I've got it.
Okay. पूछ लो, पूछ लो, अगर जानना है तो रेडी हो जाना 6 बजे से पहले पहले। ओके जी, नेक्स्ट कह रहे the end x and the y of the loop are connected to a battery using the brushes and the split ring commutator. Battery and split ring commutator. State why the split ring commutator is used. So why do we use a split ring commutator? We just gone through that question times and again. There are 3 points in this one, that it reverses the direction of current as it passes, yeah, at it as it rotates 90 degree. Okay, is this first point clear?
Yes.
Okay, in this way the coil rotates continuously in the same direction, rotates continuously in the same direction. Is it clear to you?
Yes, sir.
You have to recall this, और ये function आएगा ही आएगा, लाजमी पूछेगा वो. What is the function of the commutator? So commutator is that device which makes the coil to rotate continuously. And how does it do that? By reversing the direction of current in the coil when coil moves 90 degree, or when coil rotates 90 degree. इसमें कोई confusion तो नहीं है? ठीक है, क्लियर, आगे चले.
With question 6, sir?
Yes, yes.
Yes.
Why are you so absent, huh?
I'm not absent, sir. It's because like you said that like should we go ahead and you were already on this question. I thought you meant you wanted to skip this question or something.
Okay. Sorry. Okay, the figure 9.1 shows a wire held between the poles of the magnet carrying the current in the direction of the direction of the arrow. Right. On figure 9.1, draw an arrow label F to show the direction of the force acting on the wire. Yes. Where would be the direction of the force, or what would be the direction of the force? Yes.
Yeah, I'm doing the Fleming's left hand rule.
Yes, do it.
Uh,
Shabash.
well, we need to go. The force is downwards.
Yes, very good. Good, okay. Shabash. So you are not supposed to draw all these 3 arrows, because I have compulsion to draw these 3. तुम्हारी compulsion नहीं, you will draw just one. Okay, then question number 2. Explain why the force acts on the wire. This is frequently asked question, that why the force acts on the wire. So in the wire, its own magnetic field is interacting with the magnetic field of the magnet, because when the current will flow through the wire, there would be a magnetic field around it, is it? So you will say the magnetic field of wire interacts with magnetic field of magnet. That's why. Clear?
Clear, sir.
Okay, then the direction of the current and the magnetic field are both reversed. State what is the effect on the force. Yes, I want or I would be happy to hear the answer from you.
Um, I think the force will remain the same because if the direction of the current and the magnetic field are both reversed, they'll cancel each other out.
Very good, yaar. You are so like ladki. Very good.
Thank you.
Force remains unchanged. A force remains in the same direction. Next, so the negatively charged. This is a negatively charged particle traveling in the vacuum into the region where the magnetic field acts in the magnetic field. Yeah, shown by a cross. It acts into the paper. Into the paper means you have to point your index finger into the page. So just do it. Point your middle finger, index finger into the page and apply this by your right hand rule. What is the direction of the uh, pointing of your thumb?
Um,
Yes, where is your
if
thumb
my
pointing?
thumb is pointing upwards, but this is an electron, that means that the direction of the force should be moving downwards.
Yes, it would be deflected downwards. Very good. So you have to draw an arrow here. This is the direction of the force. So you will score 1 mark. Got it?
Got it.
Okay. Describe the path of the particle as it continues to move through the magnetic field. So when this particle will move continuously in the magnetic field, actually it would move in a circular path, right? It will move. It will move in a circular path because I will explain it with the diagram. Don't worry. Just I'm going to write the answer to make it clear to you, and then I will draw its diagram. Because the force acts towards the center of the path. The force acts towards the center of path. Yani, force will change its direction. This is uh, this is an important question. We must have a clear concept of that. And for example, if I have a magnetic field, this is a magnetic field. Cross means into the page. Okay, this all is your magnetic field, and by this, an electron is entering inside, whatever the charge is. But if this electron is in, let's say I'm going to make this possible that electron is entering from this. So it has some velocity v. So it will not just directly go down. It will move forward. Is it?
Yes.
So when it will move a little bit forward, then its actual path is this way. Its actual path is this way. I will draw both of these lines with its actual path. This is its actual path. This is, and because the force is acting downward, this is its motion. Got it? And this is the force acting on it. Due to that, it will make a settlement and it will move in this direction. This is the deflection, you can say. Then at this point, if I see at this point, the actual direction would be now in this way. This is the direction of motion possible. But here, can you apply the thumb rule, please? It would have a force in this direction. ठीक है ना? Due to
Uh,
that, instead of going in the direction of green, it would be tilting its direction downward. Okay, and
right.
then its direction should be this way. Its direction should be this way. I'm saying it should be this way, but when it is in this direction, the force will be pointing towards here, towards this center. So yes, but instead of this, it would be coming down. ठीक है? And now if you will apply the direction of the force on that, क्या होगा basically आपके पास? It would be more bent. The direction of the force will be uh, force will be acting in this direction, and in this way the particle will try to move back this way, this way, and so on. तो बस ऐसे चलाते जाएं आप, ठीक है? And this way. So did you see the direction of force is always toward the center? So if I just make a circle here, right, and I show you the direction of motion of the particle and force, so it is just like the circular motion, right? This is its velocity v, and this is the force acting on the particle. If I say that the particle is entering here, this is the force, this is its velocity v, this is this is its force, and this is its velocity v. Okay, so you will just write the object or this um, charge will move in a circular path when it will be continuously moving in a magnetic field. Why do we say that? For example, in the magnetic field, it will be in a circular path or a curved path. But when it move out, because there is no magnetic field, so it will move in the same direction by which it is emerging out of that.
So it's not
Clear?
gonna fall, it's just gonna go downwards and then it's gonna go in reverse. It's gonna go and make
Yes,
a circle.
exactly. Exactly. अब देखो इसीलिए उसने क्वेश्चन क्या पूछा हुआ है? Draw an arrow and label F show the direction of force on the particle point P when it enters in the field. Okay, good. बस ठीक है. अच्छा. When it enters in the magnetic. So right at this point, force is downward. But due to that, instead of moving forward, it would be tilted this way. ठीक है ना? So here the force will be this way, right? So it will not let it to go in the straight. It will drift its direction this way and so on. तो फोर्स की डायरेक्शन हर पॉइंट पे क्या हो रही है आपकी? चेंज हो रही है. दिस इज द प्रॉब्लम. दैट्स व्हाई एग्जामिनर आस्क्ड यू जस्ट व्हेन इट एंटर्ड. ठीक है ना?
I've got
Everybody's
it, sir.
clear? Got it or not got it?
I've got it, sir.
Very good. Explain what is mean by DC motor. Yes, explain to me. In
Direct current motor.
an electromagnetic device which converts electrical energy of direct current into mechanical energy. Got it. Electrical energy of direct current to mechanical energy. Is this clear? Hmm?
Yes, sir.
Okay. Then figure 9.1 shows the coil supplied with current using a split ring commutator. Split ring आ गया ना तुम्हारा split ring commutator. ठीक है? See that motor. This is the these are the magnets, north and south. Split ring commutator is there. Battery is connected with the motor, and this I mean this setup. This is just a support. It has nothing to do with the magnetism. ये just magnets के लिए support है. ठीक है? तो कह रहा है कि state and explain any motion of the coil. You have to state and explain also. So what will happen, or what do you think? What do you observe? The magnetic field is from north to south. ठीक है? This is your index finger, and the current is entering from left side because sorry, from the right side because positive is here. Current is entering from this way, and when the current is entering in this way, the current would be here, and then here current will be in this direction, and here the current will be opposite in direction. ठीक है? तो फोर्स किस डायरेक्शन में होगी?
Um,
Downward. Is it? Do you agree?
wait, I was
देखो, मैग्नेटिक फील्ड इज देयर, मैग्नेटिक फील्ड इज देयर, रेंज अच्छी है
But
इसकी।
sir, if the
Mag-
current is entering through the area where you've put it, then why would the
हाँ हाँ,
current at that section be downward? Like the force, why is the force downwards over there?
आप हाथ से चेक करो ना इसे।
Oh, okay, wait.
Isn't it your force in the downward direction? Check it out.
Okay, wait, hold on.
Is it?
Wait, FBI. So yeah, okay, you're right.
Yes. So thumb is pointing downward. This is actually on that side, and on this side, uh, this is the direction of B. I will just draw it on that side so that I would be able to explain it to you. This is the direction of magnetic field, and what is the direction of current then? The direction of current is in this way. ठीक है ना? Current अब अगर इधर हो गया, so just show your thumb. Where would be your thumb pointing? Isn't it upward? Is at this point. ठीक है? Is it clear to you?
Yes, sir.
Okay, so there is a rotation. So I explained it to you that what will be the direction of rotation. The rotation is basically your clockwise, है ना?
Yes, sir.
So you will state it that there
Clockwise motion.
is a clockwise rotation, motion नहीं, clockwise rotation. ठीक है? पहली बात. So you will secure 1 mark here. Then for rest 2 marks will be awarded to you as when you will write that due to the magnetic field of coil, magnetic field, or here I will add one more word, due to interaction of magnetic field of, due to interaction of, interaction of, do you understand what does it mean by interaction of? Because there are two magnetic fields now. Interaction of magnetic field of coil and magnet. The force is developed and its direction is determined by using Fleming's left-hand rule. Got it? Its direction is determined by Fleming's left hand rule. You got it? You have explained everything, that it's what will happen and why will it happen and how did I knew it will be clockwise. सही है?
But like, sir, why do we have to write the force is developed?
Develop mean if there would be no current, there would be no force developed across the wires.
Right.
ठीक है ना? अब force develop की बजाय आप ये भी लिख सकते हो force is produced. ठीक है?
Yes.
Yes, state 2 changes to the electrical device that would make the coil to rotate faster. हाँ, पानी पिला दो बेटा बाबा को. हाँ, पानी डाल के दो. अच्छा, तो बताइए आप कॉइल को कैसे फास्टर मूव कर सकते हो? बाय इंक्रीजिंग करंट इन द कॉइल ठीक है ना, मैंने आपको NABI का रूल बताया ना, ऐसे ही है ना बच्चे, 1 because you have to state 2.
Yes, learned with
नहीं बस
Nabi.
मुझे ग्लास दे दो। Jazakallah. Yes, by increasing current in the coil, right? By increasing number of turns of the coils, by increasing area of the coil, or this is the last point I am going to write. Uh, Wind the coil on the iron core, right? Or use the stronger magnets around. ठीक है ना? Or use strong magnets around. ठीक है? B. Is it clear to you? Yeah, Riba?
Uh, yes, sir.
देख लो, ये तुम रुक के ये सर
If you
कहती हो ना,
put it
मुझे
in a
थोड़ा
different formation, so it was a bit surprising because you always write it as Nabi, so I was just reading it carefully.
ओके ओके ओके, हाँ बस वो कभी नंबर ऑफ टर्न से स्टार्ट करते हैं लेकिन यू कैन स्टार्ट फ्रॉम दिस NABI, ठीक है? सो हेयर मोर फिजिबल इज इंक्रीजिंग द करंट, नंबर ऑफ टर्न्स एंड सो ऑन, ठीक है?
I've got it, sir.
वेरी गुड. Is it visible and clearly explained or not?
It is, sir.
Okay. Correct. Student question number 8. Oh my God. We are at question number 8. We are just left with, I think, 2 more questions. Generator ke questions are. Acha, correct. Student turns the handle of the alternating current generator. And the coil rotates on figure 8.1 represents the structure of the AC generator. Just recognize that. What is the difference between the structure of AC generator and DC motor? क्या difference है? Did you notice?
The
Coil
split
magnet same, carbon brush is same. Instead of slip rings here in motor, there is a split ring, a single splitted ring, a single ring, splitted one. So this is your motor. This is what? This is motor. This is generator. Is that difference clear?
yes, sir.
Okay. अच्छा, उसके बाद आपको बोला there is an alternating voltage output between the two terminals. Explain why the rotating the coil produces an output voltages. Yes, I need answer from your side. 3 marks. When the coil is rotated, यहाँ से start करो शाबाश.
Okay. It's because when the coil rotates, it cuts the magnetic field lines, which
Perfect.
induces a current.
Well done. मुझे लिखने भी दो अब साथ साथ. It cuts the magnetic field lines. Got it?
Which
And
induces a current.
induces EMF or current in the coil. Current in the coil, yes, which appears as an output, which appears as R. Okay, 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 just a second. I'm going to write one more statement for you, which is fed to the output via slip rings and carbon brushes. Do you see? There is something new for you, na? That induced current is basically delivered to the output, right? To that point with the help of what? बताइए.
Um,
Slip ring, slip ring, and carbon relations. Because this everything we just said कि current is induced in the coil ना. मेरी बात सुन रही हो? What did we
right.
wrote? कि
The
coil
the
पे current
the
induce
coil
हुआ. But the question is how did it reach to the output?
using the slip rings and the
Yes, the current would come to the output through this from the coil to this slip ring and to this carbon brush and so on. And from this it will go back and so on. बात समझ आ रही है?
yes, sir.
Very good. Move to the next. State the position of rotating coil when the alternating voltage is maximum. Frequently asked question. Where is the coil? Where is the output maximum? I have explained this question to you. If you believe and remember that this is the initial value, this is the 90-degree rotation, this is 180-degree rotation, this is 270-degree rotation, this is 360-degree rotation, right? And the position of the coils, I'm not going to draw the position of the coil. Then current यहाँ पे क्या होता है? Zero. For 90 degree it is maximum, and for 80 degree 180 degree it is again zero, and for 180 degree, yeah, 270 it is again maximum, 360 it is zero. So you will draw it in this way. But problem is, what is the initial position of the coil? Initial position of your coil is vertical. ठीक है? This is horizontal position where your current is maximum. Again, the coil is vertical here. Again, the coil is horizontal here. Again, the coil is vertical here. So this is the game of generator. देखो आपने क्या किया? If you are going to rotate it in this way, this would rotate in this way, then this would be down, this would be up, then this would be in this way, this would be in this side. ठीक है? बात समझ आ रही है बेटा? This is the cross section of the coil. I'm just showing you the position of the coil. And if this is your side, बल्कि एक और काम कर लेते हैं आपको आसानी के लिए. I'm just going to give you the color scheme. Just follow this blue arrow. When this blue arrow will be back on its position, so here it will be back on its position, isn't it?
Yes.
So it is 360 degree rotation. यहाँ पे आपको 180 मैंने शो किया ना, यहाँ पे देखो ब्लू अप है, यहाँ पे ब्लू डाउन है. Are you getting what? No point. So you will simply say that state the position of the rotation and alternating current is maximum, and explain why the maximum current output is at this position. तो आप सबसे पहले क्या लिखोगे? At horizontal position. एक नंबर आपने यहाँ सिक्योर कर लिया. ओके जी? At horizontal position. And one more mark will be awarded to you. That mark will be that because rate of change of flux is maximum here, because rate of change of flux. I told you that what does it mean by flux? Magnetic field strength. Magnetic field strength. ठीक है? Rate of change of flux किसको बोलते हैं? Change in the strength of magnetic field. Rate of change of magnetic field strength is maximum there. I mean at the horizontal position. Is this clear to you? Do you understand the game? Huh? Clear है बच्चा?
Can I just like look at this for a sec?
Yes, yes, yes. Why not? Look at it. Look at it.
I get it, sir.
अच्छा 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 बस शुक्र अल्लाह ना मैं चक्कर लाया था तो अंदर लेकिन
Sir, is everything okay? I can't hear you.
अच्छा ठीक है मैं फिर चक्कर लासा ना दूसरा बहुत तो फिर इसकी चेंज कराएंगे इसमें ठीक है हाँ क्योंकि आज मैं मार्केट पूरी फ्री लेकिन मैं की कोई यानी ना ना कोई मसला नहीं मैं आज ओके जी सो सॉरी आई गॉट अ कॉल तो हम लोग कर रहे थे क्या यस वी आर ओवर हियर इज इट क्लियर टू यू
Yes, sir.
okay go back to this question a lamp and the open switch a lamp and an open switch are connected to in series to the output terminals of the AC generator. The switch is closed and the lamp lights up. The student has to apply greater force on the handle. Oh, what a question! Yeah, perfect question. After a long, long time, I just seen this favorite question of mine. देखो वो कह रहे हैं कि when the switch is closed and lamp lights up, the student had to apply greater force on the handle. Explain why the greater force is needed to keep this lamp lit. Okay, go back to this question. Now, instead of this output voltage, what do we have? We have uh, a closed switch, sorry, open switch, and a lamp, and that lamp is connected here. So it is said that when this switch is closed, the lamp lights up and the student has to apply a more force over here. This question is amazing question. पहले मैं आपको इसके बारे में सारी डिटेल बताता हूँ. Then we will write about that. The problem is when a coil or a wire is moved in a magnetic field, actually what happens? It uh, it has an induced current in such a way that it opposes the motion of the magnet. आपको Lenz's law मैंने पढ़ाया था ना, है ना? Lenz's law is that if you are going to bring a magnet closer to this coil, then what will happen? This is the north pole of the coil and the south pole. So you are bringing north pole closer to this coil. So what will this coil do? This coil will produce north here, right?
Right?
And south here. It will cause a repulsion, isn't it? I mean, it will oppose its motion, na? This was the Lenz's law. Are you getting it? When a magnet
Yes.
brought closer, should I write or is it clear to you?
If you can write it, that would be helpful, sir.
Okay. When a magnet is brought, magnet, MAG stands for magnet, brought closer, our magnet's north pole, simply north pole, is brought closer to end X of the coil, and X, this is end X, this is end Y, and X of coil, it re- it opposes its motion. Yani coil opposes its motion by generating or by inducing. Yes, I got a good word. Inducing opposite pole on end X. Sorry. Not opposite. Like pole. Because repulsion takes place where? Induces like pole at end X. Just go through this statement and this diagram. See that. When you are going to bring north pole closer to end X, and X does not have any communication method that it will say, okay, down, come to me. क्या करेगा coil? I mean, how a magnet can be stopped or how a magnet can be opposed to come towards by creating a like pole ना repulsion करना चाहिए ना इसको. देखो मैं दोबारा पूछ रहा हूँ, आर यू गेटिंग माई पॉइंट और नॉट?
I'm a bit confused.
देखो मेरी बात सुनो. लेट्स से तुम्हारा इस सारी सिचुएशन में तुम यूं समझ लो कि तुम्हारा जो रोल है वो एक कॉइल की तरह का है, ठीक है? सही. यू आर अ कॉइल
Okay.
और तुम मामा के सामने बैठ के क्लास ले रही हो, ठीक है? अब
Okay.
मसला ये है कि मैं ये कह रहा हूं तुम्हें, मैं एक मैग्नेट हूं, मैं ये कह रहा हूं कि अभी हमने और पढ़ना है, ठीक है? तुम मुझे
Right.
मना नहीं कर सकती क्योंकि मामा के सामने बैठी हुई हो. सो तुम सिंपली क्या करोगी, या तो मुझे टेक्स्ट कर दोगी या फिर कहोगी सर आज के लिए काफी नहीं है. डायरेक्ट मना तो नहीं किया ना तुमने.
जी.
अपोजिशन कैसे की तुमने? बाय द सेम काउंटर स्ट्राइक. मैग्नेट के नॉर्थ पोल को अपोज करने के लिए व्हाट डू आई नीड? अ लाइक पोल ना, रिपल्शन करनी है ना?
Yes.
अगर मैं नॉर्थ को, ये आपके पास एक नॉर्थ पोल है एंड दिस इज योर साउथ पोल एंड यू वांट, दिस इज मूविंग इन दिस वे, सो यू वांट टू स्टॉप इट, सो व्हाट विल यू डू? Either you will apply your hand. No, we will not. We want to stop it by magnetism. So when we want to stop it by magnetism, so how will it be stopped? If there is a magnet in front of it and it has the same north pole, if there is a magnet in front of it and it has a south pole, so its motion would be faster, is it?
Yeah.
मेरी बात, इसका मतलब ये हुआ कि just assume this coil as this magnet, that if this coil wants to stop it, it must produce north on the end X. Is it? है ना?
Yes.
गाड़ी में कब आएंगे?
Is it clear?
Yes.
So this is what I have stated in this statement. ये जरा तुम्हें सारा समझ आ गया?
I think so, sir. I think mainly the most confusing part is the inducing from the end.
नहीं, inducing का मतलब ये हुआ कि at the end x temporarily it is causing a north pole. Now go back to the mechanism. The north is moving away, right? North is moving away, and this coil is going to stop it. This coil is going to stop it because this is the behavior of the coil. It want to stop it. So instead of this, if this coil is a permanent magnet, then what will that do? बताइए. Or how can I stop this away moving north by a magnet? So if my magnet is having south here and north here, then this south will attract it, है ना? And it will not let it to go away. Are you getting my point?
Yes.
It means that now end x of the coil will produce, this is your end x of the coil and this is your end y. Now this x is south. बस आप लोग तैयारी पकड़ो. दो क्वेश्चन रह गए. And this end x is of the wire is south and end y of the wire is north.
सारे कपड़ों का हमने के इंफिनिट सब हमने के ये भी हमने के ही था ना, इसका भी वो काला है पूरा.
बात समझ आई है तुम्हें? क्लास ले रहा हूं.
Yes, sir.
इसलिए देखो आपकी एक ही कॉइल है. Once it is producing north on end x, once it is producing south on end x. So isn't it temporary polarization?
Yes.
So that is why I called it induces. ठीक है? Induce का मतलब होता है temporarily. बात समझ आई है? आगे चलो.
Yes, sir.
Okay. अब देखो, अब दोबारा इस पे आना है. देखो क्वेश्चन समझा रहा हूं. When your north pole is brought towards the coil and there is a north ahead, so will you apply more force to insert it or not?
Sir, could you repeat that? I didn't understand.
I'm saying,
Your voice cut off.
I'm saying that if you have a magnet and in that mean for that magnet you are moving it simply, no opposition was there, so you were applying a force F. Okay, let's say it was of 2 Newton. Is it clear to is it clear for you? Clear to you?
Yes, sir.
Now you are moving the same north pole in front of a magnet in which there is a north pole. So if you want to move this blue magnet closer to this north pole, so what you have to do? Will you be required more force or not?
More force.
Yes, because there is a repulsion. Is it clear?
Yes, sir.
Okay, so in the same way, when you are going to rotate a coil in a magnetic field, this coil has an induced EMF, and that induced EMF opposes the motion of the coil. And due to that, we have to produce or we have to apply more force. What we have to do? We have to apply more force to rotate it. So I will write in this way that due to induced, you are not supposed to write again the detail that magnetic field lines are cut, magnetism is EMF is induced. No, due to induced current, the motion of the coil is opposed. Motion of the current is opposed according to Lenz's law. According to
5%
Lenz's law. You have to refer this one. Lenz's law. Okay? That's why to overcome that opposition, to overcome that opposition, more force is required. More force is needed. ये बात clear है? Is this clear to you?
Yes, sir.
Okay. Two questions are now in the pool. One is 10.1 shows a simple alternating current generator, right? AC generator. On figure 10.2 sketch the graph to show the electromotive force induced on the wire with the time t, right? Label the points on the time axis where it completes 1/4 of the revolution and 3/4 of the revolution. So we did that already. ठीक है, आपको ऐसे करके ड्रॉ करना है, राइट? सो इफ ही हैज आस्क्ड यू टू ड्रॉ वन सर्कल, ठीक है, वन रेवोल्यूशन के लिए उसने कहा ना यू हैव टू डू इट वन. तो वेयर इज द टाइम division? It is first quarter, so it is first t by 4. It is second quarter, so it is half t by yani t by 2 because half of the cycle is done. Then it is 3t by 4 and then it is complete t.
How come we have to say T, sir?
Because in complete time period, one oscillation is complete. Na? Time period is t. Okay?
Got it.
तो तैयारी करो जल्दी. Okay जी, is this clear to you? Sorry for intervention.
It's okay, sir. Is everything okay?
I was corrected by my daughter that no, it is not intervention, it is interaction. Sorry, interruption. Ah, very good. अच्छी like हो गया तुम. Okay, so explain why an EMF actually they have to move outside in a school function. They are invited at 6 o'clock. So they are now
Oh,
wandering here and there. Abbu कब free होंगे? So
oh. Tell them I'm
हाँ.
sorry from my side.
No issue because function will not start as immediate at 6 o'clock. It will take time.
I hope so.
Yeah, because most of the time it happens that We are asked to 6, but it starts 6:30. It takes time. अच्छा,
Is
तो
this
उसके
a
बाद
common
है
occurrence in Pakistan?
sorry, can you
Is
repeat?
this a common occurrence in Pakistan?
Yes, very common.
I had a feeling.
Yeah. Can I explain why the EMF induces only between the coil is when only when the coil is turning? So, as I told you, that to induce the EMF, the coil must rotate, isn't it? So, when the coil rotates, the magnetic field lines are cut. When the coil rotates, the देर इज हाँ ये ऐसे लिख देना तुमने इसका एक नंबर का आंसर है तो आई वुड ट्राई माय बेस्ट टू मेक अ गुड कंप्रीहेंशन हियर देयर इज अ चेंज इन cutting of magnetic field lines. Yeah, there is a change in magnetic flux भी लिख दो, it would be fine. The cutting of magnetic field lines. ठीक है, या आप इसका आंसर ये भी लिख सकते हो कि there is a change, रोटेट के बाद लिखना है, ठीक है, एज अ कॉइल यहाँ के बाद चेंज इन मैग्नेटिक फ्लक्स. सही हो गया? क्लियर? यस अरिमा,
Yes, sir, I've got it.
very good. Now state the name of the components labeled P and Q. State the purpose of these. P and Q कहाँ पे है? P and Q. Okay, P and Q आपका क्या है? What are these two? P and Q. They are slip rings. What are they?
Slip rings.
Yes. ये भूलोगी तो नहीं ना?
No, sir.
Okay. So they are slip rings. And what is their function? Or what is their purpose? They make a safe rotation of coil. How? Or you can extend it in this way that they are used to make a safe contact, to make a safe contact between coil and load. Actually, the load is what you have used outside. Okay, load without damaging the wires. Without damaging the wires. अब प्रॉब्लम ये है कि देखो अगर आपका कॉइल रोटेट होगा ना, ठीक, एंड these are not slip rings. Slip rings का मतलब क्या है? They will rotate, but they will not affect the position of the carbon brushes. They will just, the carbon brushes will be on their own position. This is your load. ठीक है? So they will rotate continuously, but by touching the carbon brush, they are making a safe contact between static and rotating part of the appliance. ठीक है? बात क्लियर है? अदरवाइज क्या होगा? अगर आपका कार्बन ब्रश भी इसके साथ रोटेट करना शुरू हो जाएगा तो दे वुड डैमेज द आउटपुट वायर्स ऑफ दैट, है ना?
Yes.
ये बात समझ आ रही है?
Yes.
व्हेन दे विल यानी रोटेट और कार्बन ब्रश भी साथ घूमेंगे ना तो ये वायर्स इसके साथ ट्विस्ट हो जाएंगी एंड व्हेन दे विल बी ट्विस्टेड दैट वुड बी डैमेज्ड. ठीक है? ओके, this is the last question. Explain why the core of the transformer is made up of soft iron. why the core is made up of the soft iron. As I told you, that because core links the magnetic field from primary to secondary. Is it? इधर रखो. Because actually this is the function of the core, because it links or just forget about this, because it links the magnetic field from primary coil to secondary coil. Magnetic field from primary coil to secondary. ठीक है, बात समझ आ रही है? Should I explain it or is it clear?
Can you explain this a little bit, because um I don't get it, that the linkage thing.
Yes, linkage is this. Linkage मैं तुम्हें समझाता हूँ कैसे होता है. देखो, there is a primary coil and that coil is wound or that is uh, across this primary coil. ये diagram मैंने तुम्हें बना के समझाई है वहाँ पे, अगर तुम्हें याद हो तो. Is it? This way. And this is the secondary coil. ठीक है ना? So in that one, the they have no electrical contact, neither physical contact. ठीक है ना? ये coil output coil है. This is the secondary coil. ठीक है? Output coil. And this is your input coil, primary coil. So what do? When you change the current in the magnet, yani in the primary coil, there is a magnetic field which is generated, and that is brought or that is carried out or that is fetched to the secondary coil and then brought back by the iron core. Iron core का काम होता है इसको लेके जाना और यहाँ से वापस यहाँ से लेके आना. So iron core इन दोनों के दरमियान linkage create करती है. Now you got it? What does it mean by linkage?
Can you
Hmm?
explain one more time, please?
Yes, there is another technique, and that is, for example, this is a flower vase, and you want to water it. ठीक है? ये तुम इसको पानी दे रही हो, and you have a pipe over here. Okay, you are going to throw water. So what will happen? Some of the water will enter in, and some of the water will not. Is it? जरूरी नहीं है ना सारा पानी इसमें जाए.
Right.
Okay. But instead of that, if you connect a pipe to this one and just link it to this part, so what will happen? What are you doing now? You are avoiding all losses in the surrounding. है ना?
Right.
यार इसको चुप कराओ. Is this all clear? देखो, आपने लिंक किया किसको?
The
This is the
pipe and
primary coil. Yes. This is your primary setup, primary coil. And this is the magnetic field. And you have just linked that magnetic field to the secondary coil. Is it clear? If this pipe, this blue pipe would not be there, then what will happen? Then what will happen? The magnetic field would not be linked. Is it clear to you?
yes, I've got it now.
Okay. In this way, you can say that the function of this core is just to shift the magnetic field from primary coil to the secondary coil without wastage. ठीक है? बाहर नहीं फेंकता इसको मैग्नेटिक फील्ड, यहाँ से बाहर नहीं जा सकता मैग्नेटिक फील्ड. So it has basically avoided it. Clear?
Clear.
Okay. Calculate the voltages between the terminal of the coil Q. Terminal of the coil Q. Is there any terminal? नहीं, ये आपके पास क्वेश्चन ही नहीं है. There is no diagram at all.
Is this a good thing or a bad thing?
It's a good thing. When your ma'am will give you this question, just ask ma'am that ma'am, there is this question is some part is missing. Okay, don't worry. This question is solved by this concept of number of turns on the primary coil. I'm just going to assume some values. For example, you are going to give 240 volts, 240 volts at the primary coil. This is your primary coil. So this is your VP, and there are 300 turns on the primary coil. 300 turns. Okay, and this is the secondary coil. So number of turns on the secondary coils are, let's say, 600, right? So calculate the output voltages V in the secondary coil. ठीक है, तो क्या करोगे? You will write NS divided by NP is equals to VS divided by VP. ठीक है? Did you remember this formula? We have discussed that formula in the
Yes, I
previous
remember this
lecture.
formula.
Okay, good. So number of turns on the secondary is 600. Number of turns on the primary is 300. And voltage at the secondary is required. We do not know that. But voltage on the primary are 2 240 कर लेते हैं. 240. ठीक है? Just cross multiply करो जरा. कितना आंसर आ जाएगा?
Okay, give me a sec, my calculator.
480 आ जाएगा. हो गया.
How
देखो
did you
कैसे? 300 ones, 300 twos are 600, and 240 multiplied by 480. ठीक
Mashallah,
है?
sir.
Yes.
You should seriously teach math.
टेबल याद किया ना बचपन में. Okay, I can try, but yeah, I'm in the comfort zone of physics. That's why I do not.
It's okay, sir. It's time to get out of your comfort zone.
Yes. Okay. कह रहा है कि the heater is connected in the coil Q. Q. Coil Q is maybe this one because this heater is having ठीक है, एक box. This is a box. And there are, this is a heater. ये heater का symbol याद रखना है. अगर इस तरह का क्वेश्चन आ जाए ना, तो you have to remember that this is the heater.
Sir, are you saying anything? Because I can't hear you.
Sorry, I don't
Yes.
Oh
understand.
my god, my Siri. Still can't hear you though, sir.
Yes, I was saying that heater has this symbol. Okay. अब देखो, the heater is connected to the coil. The current in the heater is
Sir?
3.5 ampere. Yes. Am I mean? Don't you hear me? Hello?
Wait, sir, can you say that again? I heard you for a second. Can you please repeat one more time?
Yes. I'm saying that now. Do you hear me?
Yes, now I can hear you.
Okay, thank you. So I'm saying that heater is connected here. So this is your I in the secondary coil. Secondary coil का current है ये IS. The this transformer is 100% efficient. 100% efficient mean this, it does not have any power loss. So when it does not have any power loss, actually, P out is equals to P in. So what is output power? As I told you, we have discussed that question. Power is equals to V into I, if you remember, right? So
Yes,
output coil is a
VIP.
secondary coil. Yes, so Vs into Is will be equals to VP into IP. ठीक हो गया? Is it clear?
Yes.
So we have VS and IS and VP also. We can calculate primary coil current. So just write in this way that Vs divided by this Vp would be shifted on the other side. Vp is equals to IP divided by IS. IP divided by IS because that is inversely proportional. Na? So Vs is how much? Vs was your 480, ठीक है? Or Vp was your 240 and IP in the primary coil we do not know and IS is 3.5 ampere. ठीक है? इसको सॉल्व करोगी अगेन वही वाला फॉर्मूला लगा दिया 2 का तो इट वुड बी 7 एम्पियर प्राइमरी कॉइल करंट आपका कितना हो गया 7.0 एम्पियर सही है एक्चुअली यू हैव टू रिमेंबर वन ट्रिक हियर ट्रिक याद रखनी है देखो नंबर ऑफ टर्न्स आर डबल नंबर ऑफ टर्न्स आर डबल डबल किया ना मैंने है ना
But where was this set again?
yeah I told you that I put number of turns double at the secondary at the output coil.
Yeah.
So when number of turns will be double, voltages will be double and current will become half. Simple. Problem ही नहीं होगा इंशाल्लाह तुम्हें.
Could you repeat this one just one more time for me, sir? I don't know,
Yeah,
it
I will write it for
went
you.
over my
I will
head.
write it for you. When number of turns are double, yeah, you can say if number of turns are double, current is double. Sorry, current is half and voltages are double. Current is half and voltages are double. ठीक है ये बात याद रखनी है because now about the relation that V is directly proportional to number of turns and I is inversely proportional to number of turns. That is the point. ठीक है clear है बेटा
Yes.
A transformer is used to step up the voltage before the electrical energy is transferred over the long distance. This question is from
Sir, are you saying anything? You said from and then it just cut off.
was gone discharged. Now do you hear me?
Yes, sir. Now I can
Yes.
hear you.
Yes, I was saying that my mic was just discharged. Its charging was over, so that is why I'm using another mic. So it's not. Okay, जी. तो हम बात कर रहे किसी. Yes, we were talking about this question related to high voltage transmission lines. State and atomic effect transferring electrical energy at high voltages. So to transfer the voltage at high voltage and transmit the energy at high voltages, I told you that increasing the voltage current is decreased. When current is decreased, loss is decreased. The economic. So voltages increases or increase decrease. Just it was linkage increases and so the power is decreased. This is the better of your high voltage. Yes, Ariba. Hello, Ariba. Do you hear me? Ariba?
Sir, I heard you for a sec and then it blanked out.
हमारा नेट डिस्कनेक्ट वो your voice is lagging.
My voice is like my internet's on full bar though. I'm sitting right next to the internet. Uh-oh.
एक minute. Maybe it would be the problem on this side. And now do you hear me? Hello? Yes, Ariba.
Yes, sir.
Now do you hear me?
Yes, sir. Now I can hear you.
Okay, okay. I was saying that this is the entire, I mean, the solution. So if you have any question, you can ask me.
Sir, can you repeat letter C because there was a lot of like internet breaking and everything. So
Okay, okay. Let me say it again. I'm trying to say it again. Yes. Now do you hear me?
yes, sir.
Clearly, na? Is, is my voice clear?
Yes, sir. Now I can hear you.
I'm saying that that is, I mean, completed from my side. So if you have any question, you can ask me. This is what I'm saying.
Yes, sir. I had asked if you could please repeat letter C.
Let this one, this
Yes, please.
part.
Yes, please.
Okay, okay, okay. I said that when you have the high voltage transmission lines, what do you need? You have to reduce the power loss. Okay, right? Got it? Do you hear me?
Sir, now I can hear you. Could you please just repeat one more time? I'm so sorry.
No issue, no issue. I'm saying that when you are using the high transmission voltage lines, what do you need? You need to reduce the power loss.
Yes.
So to reduce the power loss, what do we need? We have to reduce the current. Okay.
Okay.
And to reduce the current in, you know, in the transformer, when voltages are increased, current is reduced.
So then what would be exactly right to like stay an economic
Oh,
effect?
right. Because power losses are reduced now. So that is the best economic effect.
So we would just write the power loss decreases?
Yes, yes, yes. Surely you will write only this one, that the power loss are decreased, because when voltage are increased, current is decreased, and in the wires, when current will decrease, power is equal to power loss is equal to I square R. Do you remember that? Do you know that? What is
Yes.
the equation of power loss? I square R. So if you are going to, or if you want to reduce the power loss, you have to reduce what? You have to reduce the current.
Right. Sorry, sir. My sisters tried to ask me something, but then I was like, I'm taking class.
No, no. Is it clear you?
Could you repeat the second part one more time? The one you said that you have to use the current.
Yeah, I mean, I will state all these three factors one by one. Once your voltages are increased, your current will be decreased. Got
Decreased.
it?
Yes.
And when current will be decreased, your power loss will be decreased.
Okay. I've
And
got it
when
now.
power loss is decreased, definitely you are avoiding the loss. So that is the economic factor. That affects the economy. Na? If, for example, you are reducing the power losses,
I've
is
got
it?
it. I've got it now.
Okay, good. So this was all for your, I mean, this worksheet.
Okay, then sir, just one thing. Could you help me on two questions from the MCQs, because I
Okay.
reviewed the MCQ paper and I had two small confusions in two questions.
Mhm.
Just give me a sec so I can.
Which MCQs?
Question 8, sir.
Question 8. MCQ number 8.
Yes.
It is the reverse gear sound. When some car is in the reverse gear, that gives this much voice, this type of voice. Yes. What is the problem in that one?
I don't understand how the answer is what A. Like, how come it's I because I when I was doing it, I was getting C.
Okay. Which hand were you using?
My left hand.
Okay. Again, apply करो जरा. Current is entering from X to Y. ठीक है?
Yes.
Where is your index finger pointing?
But if I flip my hand, may put my index finger up. Am I? Is it because like I'm supposed to only rotate my hand? I cannot flip my hand.
Yes. You can just make it. It is very simple. आप अपने सामने हाथ रखो and just rotate it. I mean, just rotate it outwards 90 डिग्री, नॉट एग्जैक्टली 90 डिग्री, थोड़ा सा 90 डिग्री पे रोटेट करो इसे बाहर की तरफ. लेफ्ट हैंड को अपने सामने रखो. बेटा स्विच ऑन द कैमरा. कि समझ आ गया?
I think समझ आ गया है मुझे.
अब बताओ ऑप्शन ए सी है.
Okay. So nope. I'm still getting C.
स्टिल गेटिंग सी. वेयर इज योर थंब पॉइंटिंग?
My thumb's pointing downwards.
ना करो यार खुदा के लिए. वेयर इज योर मिडिल फिंगर पॉइंटिंग? टुवर्ड्स वाई और टुवर्ड्स एक्स?
Uh, wait a second. My middle finger is pointing towards X.
So point it towards y because current is getting out from positive and it is entering in negative.
Okay, I get it. Now it's becoming A.
समझ गई हो?
Yeah, it was a very weird hand kind of turn. That's why, पूरा हाथ ही तोड़कर आया हाथों में.
Yes.
Wait, let me see. I think there was one more that I wasn't able to do, so just give me a sec.
Okay. Check it out.